Binary search works on divide and conquer strategy. It repeatedly divides the problem, the search range, into smaller manageable subproblems. Well, there is a prerequisite to apply binary search on any data set. Binary search works only if the data is sorted. Without a sorted list, binary search won't work correctly. Now, how to find mid value of a data range? So, the formula to calculate mid value of a data range is lowest value of range plus highest value of range minus lowest value of range divided by 2. So, suppose, for example, you want to know the mid number that is present between 15 and 25. So, by applying this formula, you can get mid number. So, 15 plus 25 minus 15 divided by 2, that comes to 20. So, the mid number which is present between 15 and 25 is 20. Similarly, you can look at the second example. The mid value that is present between 0 and 12 is 6. So, by using this formula, you can calculate the mid value that is present in a sorted range. Okay, now let's look how binary search works. Here we have an array of numbers and we are required to check if the target element 55 is present in it. If so, return the position or index of 55 in the array. Now, if we look at this array, we see the numbers are in sorted order. So, we can apply binary search here. First, check if the target element, that is 55, matches with the element present at mid index of the array. To calculate mid index of this array, we use this formula. Mid index is equal to lowest index of the array plus highest index in the array minus lowest index divided by 2. Here in this array, lowest index is 0 and highest index is 8. So the mid value comes as 4. Now the value of the element present at index 4 is 50, which does not matches with the target element 55. Now compare whether the value of the element at mid index 4 is less than the target element 55 or greater than the target element 55. 55 is greater than 50. Since this array is sorted and 55 is greater than 50, so it's definite that 55 will be present somewhere in this array after 50. So discard the lower half of the array and search for element after 50 in the array. So need to search between index 5 and 8. Again follow the same process in this sublist of array. Mid index from 5 to 8 is 6 after taking floor value. Now compare target element 55 with the element present at mid index 6. 65 and 55 does not matches and the target element 55 is lesser than 65. So discard the elements present after 65 along with 65. Need to check only the sublist of array present before 65. Now the element present in the sublist before 65 is 55 and it matches with the target element 55. So we found the position of target element in the array, that is index 5. This is iterative approach implementation of binary search. Initially, lowest index of the array is 0 and highest index is array length minus 1. Calculate mid index of the array by applying formula low index plus high index minus low index divided by 2. In the second step, compare the element present at mid index with the target element. If it matches, then return mid index. If it does not matches, compare whether the target element is greater than the element at mid index. If the target element is greater than the element at mid index, that means element is present in the array on the right side of mid index. So set low is equal to mid plus 1 and high will be as it is, unchanged. Else, if the target element is smaller than the element at mid index, that means element is present on the left side of mid index. So set high is equal to mid minus 1. We have to iterate this process until low is less than or equal to high. If the target element is not present in the list, then what happens? Then the loop low becomes higher than the high or greater than the high, and the loop terminates and the function will return minus 1.